Section 4.1, Simplify Numerical Radical Expressions. In this section, you will understand what it means to take the square root of a number, and you will simplify numerical radical expressions using the multiplication property of radicals. A square root of a positive number x is a number whose square root is x. A square root of 16 is 14 because 4 squared is 16. A square root of 16 is negative 4 because negative 4 squared is 16. Every positive number has two square roots, one a positive number and one a negative number. The symbol, shown here, called a radical sign, is used to indicate the positive or principal square root of a number. For example, radical 16 is equal to 14, and radical 25 is equal to 5. The number or variable expression under the radical sign is called the radicand. The square of an integer is a perfect square. 49, 81, and 144 are examples of perfect squares. The principal square root of a perfect square integer is a positive integer. The chart below shows principal square roots of some perfect squares. If an integer is not a perfect square, its square root can only be approximated. For example, 2 and 7 are not perfect squares. Thus, their square roots can only be approximated. These numbers are irrational numbers. Their decimal representations never terminate or repeat. The square root of 2 is approximately equal to 1.4142135, but this decimal number never terminates or never repeats. The same is true for square root 7. You can approximate the value, however, it's an irrational number. Its approximation is shown, but because it's irrational, this decimal number will never terminate or repeat. Radical expressions that contain radicands are not perfect radical expressions that contain radicands that are not perfect squares are generally written in simplest form. A radical expression is in simplest form when the radicand, which is, when I say radicand, just recall that's what's underneath the square root sign, what's underneath the radical sign, contains no factor greater than 1 that is a perfect square. So what we will be doing in this section is simplifying radical expressions. And we're going to do that using this multiplication property of radicals. And what that says that if a and b are positive real numbers, then radical ab, or radical a times b, is equal to radical a multiplied by radical b. So this is the procedure right here that I'm going to be using to simplify radicals. I'm going to rewrite the radicand as a product of a perfect square and its other factor using this multiplication property of radicals. Then I'll take the square root of the perfect square. Now these first couple are easy because they are perfect squares. The square root of 16 is equal to 4 because 4 squared is equal to 16. Notice once you take the square root, you no longer need that radical sign. The square root of 16 is equal to 4. The square root of 36, well, 36 is a perfect square, so the square root of 36 is equal to 6 because 6 squared is equal to 36. Notice once you take the square root, you no longer have the radical sign over the 6 and the 4. Now, if you go to take the square root of 32, there's no number multiplied by itself that is equal to 32. No number squared equals 32. Therefore, 32 is not a perfect square. So what we're going to try to do is we're going to pull all the perfect square factors out of 32 using that, and we're going to be using that multiplication property of radicals to help us do that. So what I'm going to do over here is I'm going to do a factor tree for 32. And it doesn't matter what factors of 32 you start with. Okay, so I'll just say, okay, 4 times 8 is 32. And 2 times 2 is 4. 2 and 2 are prime. I know that 2 times 4 is 8. And I know that 2 times 2 is 4. And at this point you're looking for pairs. So you can see you have a pair of 2's. Okay, because the prime factorization is 2 multiplied by 2. Or let me erase this for a second and just show this a little differently. Where's my eraser? Felt tip pin. Okay, so the prime factorization is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. Okay, and now I'm looking for pairs because that is a perfect square. Okay, 2 times 2 is 4. 4 is a perfect square. 2 times 2 is 4. 4 is a perfect square. And then you have a leftover 2. Okay, so 4 multiplied by 4 multiplied by 2 is 32. That's how I'm going to rewrite radical 32. I'm going to rewrite it as radical 4 multiplied by radical 4 multiplied by radical 2. Okay, using that multiplication property of radicals. Now I'll take the square root of 4, which is 2, multiplied by the square root of 4, which is 2, multiplied by, well, I can't take that square root of 2. That's the irrational part. Now I'm just going to multiply 2 multiplied by 2 is 4, so I get 4 square root 2. You can read that as 4 times the square root of 2, or you can read that as 4 square roots of 2. Alright, let's try the next one. Square root 8. Let's simplify that. I'm going to do a factor tree for 8. 2 multiplied by 4 is 8. 2 multiplied by 2 is 4. So the prime factorization is 2 multiplied by 2 multiplied by 2. And I'm looking for pairs. You have one pair. That perfect square is 4. You have a leftover 2. So when you split up radical 8, you're splitting it up as radical 4 multiplied by radical 2. And now you're ready to simplify. The square root of 4 is 2 times square root 2. You'll just write that as 2 times the square root of 2. Or you could read it as 2 square roots of 2. 2 radical 2. Negative 3 times the square root of 48. Now that negative 3, notice, it is not underneath the radical sign. That is just a negative 3. So I'm paying attention to the 48. I'm going to do a factor tree for 48. 3 times 16 is 48. 2 times 8 is 16. 2 times 4 is 8. 2 times 2 is 4. And we're looking for pairs. Okay? So I have a pair of 2's. 2 times 2 times 2 times 2 times 3 is the prime factorization. Pair of 2's, that's a 4 multiplied by, there's another pair of 2's, there's a 4 multiplied by a leftover 3. That leftover part is always going to be the part under the radical sign that remains irrational. So this negative 3 I'm just dropping down. So I'm going to have a negative 3 multiplied by radical 4 multiplied by radical 4 multiplied by radical 3. So the 4 times the 4 times the 3 under the radicals is what equals the radical 48. The negative 3 I just dropped down. So now I'll simplify. I have a negative 3 multiplied by the square root of 4 is 2, multiplied by the square root of 4, which is 2, multiplied by radical 3 just drops down. And now negative 3 multiplied by 2 multiplied by 2, you just multiply those together. 3 times 2 is 6, 6 times 2 is 12. So we get negative 12 times the square root of 3, or negative 12 square roots of 3. All right, let's simplify 11 times the square root of 80. We'll do a factor tree for 80. I know that 8 times 10 is 80. I know that 2 times 4 is 8. 2 is prime. I know that 2 times 2 is 4. And I know that 2 times 5 is 10. All right, so I have my prime factorization is 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 5. So there's a pair of 2's, that's a 4. There's a pair of 2's, another 4, and I have a leftover 5. So that's how I'm splitting up my radical 80. I'm going to have 11 times radical 4 times radical 4 times radical 5. The radical 5 is the irrational part that stays under the radical when you're finished. So I'm going to have 11 multiplied by the square root of 4 is 2, multiplied the square root by another square root 4, which is 2, multiplied by square root 5. So now you're going to multiply 11 multiplied by 2 multiplied by 2. 11 times 2 is 22. 22 times 2 is 44. So you end up with 44 times the square root of 5, or 44 square roots of 5. All right, square root 324. Now, when I first saw this number, what you may want to do if you have a calculator on yourself is take the square root of the number, like push the number into your calculator. Take the square root of it to see if it's a perfect square to begin with, is often what I will do. Because what I did is when I did a factor tree for this, if you do a factor tree, like if I break this down 2 and 162, and then 162 will go to 2 and 81. And then 81 goes to 9 and 9. So you see all you end up with is pairs. You have a 2 multiplied by 2 and a 9 multiplied by 9, right? So that's a perfect square 4 and a perfect square 81, which means this would equal radical 4 times radical 81, right? Which is just 2 times 9, which is equal to 18, which means, whoops, the pen is not wanting to write. Uh-oh. Whoops. So which means if you took the 324, it's just equal to 18, because 18 times 18 is 324. 324 is a perfect square, okay? So if you would have just taken the square root of 324 on your calculator, you would have gone directly to 18, which is just fine, okay? All right, let's simplify square root 250. 25 times 10 is 250. 5 times 5 is 25. 2 times 5 is 10. I have a pair of 5 times 5. I'm just going to keep it in that order because you can see your pairs right there, 25. You have 2 leftovers, a 2 and a 5. Just multiply that together, okay? So you're going to have radical 25 multiplied by radical 10. Take the square root of 25, which is 5, so you're going to get 5 times the square root of 10, or 5 square roots of 10. Right, square root 160. 10 times 16 is 160. 2 times 5 is 10. 4 times 4 is 16. Each of those 4s goes to 2's. So we have 2 multiplied by 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 5. There's a pair. There's a perfect square. Another pair of 2's is another perfect square. A leftover 2 and 5 makes... Oh my goodness. Fighting with my pen today, I see. I'm sorry. Bear with me. I don't want to have to start over. So we have a 4 and a 4 and a 10. Just take a moment, I guess, and hopefully my pen will start working. Sorry, I'm holding you up. Oh. Did something. Come on, come on. It is definitely not wanting me to write. Darn it. I was almost done with this lesson as well. I hate to have to start over again. Alright, maybe it'll start now. Alright, are you still with me? Okay, so we're going to rewrite this as radical 4 multiplied by radical 4 multiplied by radical 10. So that's going to be a 2 multiplied by 2 multiplied by radical 10, which is going to equal 4 times the square root of 10, or 4 square roots of 10. Alright, and we'll do one more before the U tries. So I'm going to do a factor tree for 288. Now, I know that 2 goes into 288 144 times. Now, if you wanted to, you can continue to break down that 144, guys, but I recognize that 144 is a perfect square because 12 times 12 is 144. So I'm just going to stop right there, and that's how I'm going to split up the 288. So I'm going to drop down my 9. I'm going to rewrite 288 as radical 144 times radical 2. So I'm going to have 9 times the square root of 144 is 12 times the square root of 2. 9 times 12 is 108. So I get 108 times the square root of 2, or you could also read that as 108 square roots of 2. Alrighty. Alright, I'll go ahead and end there. Sorry about the hang up on the last couple. Hope this is enough to get you started on your homework and quizzes. Alright, have a good day.